PreUPS3 extra for topic polynomials and trigo functions. Number 1. Find the quotient and remainder when this polynomial is divided by x minus 2. Okay, first thing, change to long division. You have to do long division. 2x cubed minus 5x squared plus 3x plus 7. Make sure the degree is decrease. Okay. Then the next step is you're going to get rid of this by multiplying x with the 2x squared. So 2x cubed, okay, minus negative 4x squared. So minus, so is negative x squared. The next step, bring this one down, plus 3x. Next step, you want negative x squared. Multiply x by negative x, so negative x squared minus plus 2x. Negative x squared minus, so 0. 3x minus 2x, x. Next step, this 7 down here, plus 7, and x times 1 equal to x. Negative 2 times 1, negative 2. Then x minus x, 0. 7 minus negative 2 is 9. So this is quotient. X squared, 2x squared, quotient 2x squared minus x plus 1. Remainder is equal to 9. This is remainder. So the answer is 2x squared, for this one no, 2x squared minus x plus 1, 9. Answer is here. Okay, settle. For number 2, find the value of k if x plus 1 is a factor of this. When the factor of this, substitute x plus 1 is equal to 0, so x is equal to negative 1. Substitute negative 1 in this variable, and the answer is equal to 0. So 4 negative 1 cubed plus 3 negative 1 squared plus 4 times negative 1 plus k is equal to 0. Negative 4 plus 3 minus 4 plus k is equal to 0. Negative 8 plus 3 negative 5. Therefore k is equal to 5. K is equal to 5. So it's this one. Okay. Number 3. When the polynomial pt is divided by p minus 1, the remainder is negative 5. P of 1 is equal to negative 5. Find the value of h. Okay, substitute k here. This is variable. Variable is equal to 1. Substitute p of 1 is equal to 4, 1 cubed minus 2, 1 squared minus h is equal to negative 5. 4 minus 2 minus h is equal to negative 5. 2 bring up here, negative 7. Therefore, h is equal to 7. Okay, so the answer. Number 4. The polynomial px has a factor x plus 3. So p of negative 3 is equal to 0. And leave a remainder of 4 when divided by x minus 1. Leave remainder 4 when x is equal to 1. So two equations, okay, first, second, and to find the constant m and n. Two equations. So substitute, okay, this polynomial. So the first one is p of negative 3 is equal to 0. Okay, so substitute, replace all this variable, okay, by negative 3. P of negative 3 is equal to m negative 3 cubed minus negative 3 squared plus n negative 3 plus 12 is equal to 0. To show this is 0 a factor. Simplify negative 27m minus 9 minus 3n plus 12 is equal to 0. Simplify negative 27m minus 3n. This one is equal to 3, so negative 3. Divide all by negative 3, like 9m plus n is equal to 1. This one equation. And for the second one, p of 1 and substitute x by 1, m1 cube minus 1 squared plus n1 plus 12 is equal to 4. Then simplify. Then m plus n is equal to 11 bring to right negative 7. So you get two equations for the constant m and n. Okay, this one equation 1, equation 2. Equation 1 minus equation 2. So 9m plus n is equal to 1. M plus n is equal to negative 7 minus. So minus, answer is 9m minus m, 8m. N minus n 0, 1 minus negative, so 8. Therefore, m is equal to 1. Substitute into the equation 2 to find n. 1 plus n is equal to negative 7, therefore n is equal to negative 8. So m is equal to 1, n is equal to negative 8. 1, negative 8. 1, negative 8. So this is the answer. Okay. Number 5. What are the zeros for this function? So this one, f x, okay, because of this one, okay, every terms have x variable, so take x as a factor. Okay, take x as a factor. X 3x cubed minus 12x squared minus x plus 4. We're going to concentrate this one this time. Okay. So just concentrate this one to find the zeros. So one of the zeros. So okay, to find the zero, just check the constant here. Okay, substitute either plus negative 1 or plus minus 2 or plus minus 4. Okay, substitute when you get 0, and that shows that this is a 0 for this fx polynomial. Try an error. Okay, let's try. First substitute, let's say negative 1. Okay, substitute here we're using this one. Okay, so negative 3 minus 12 minus positive 1 plus 4. Okay, this one not equal to 0. Settle. f1 substitute here. 3 minus 12 minus 1 plus 4 also looks like not equal to 0. And f negative 1, negative 2, negative 8 times 3, negative 24, minus 4 times 12, negative 48, minus plus 2 plus 4. This one also not equal to 0. F of 2 substitute 8 times 3, positive 24 minus 48 minus 2 plus 4. This one, okay, not equal to 0. Then substitute f of negative. Okay, f of negative 4 substitute here. Negative 4 cube is negative 64 times 3, so you get negative 192. And this one, negative 4 squared 16 times 12, negative 192. And then here is 4, okay, positive 4 plus 4. This one also not equal to 0. And the last chance, substitute here is positive. So this one is negative. Then negative 4 plus 4. This one confirm 0, 0 is equal to 0. Then we get 1. This one is equal to 0. Therefore, 4 is a 0 for this polynomial. Okay, you can write this one. Fx is equal to x minus 4. Then we need another quadratic. Okay, ax squared plus bx plus c. Okay, compare coefficient to find the a, b, c. Okay, back. Let's say compare. Okay, just you can get rid of this one because also it's not because something. You just take this one, the yellow, only this one, on this part. This part, and this part. Okay, and then let's say compare x cube. Here is 3 and here is a. So a is equal to 3. And constant, okay, compare constant is, this one is 4. Constant, this one negative 4 times c, negative 4c. Therefore c is equal to negative 1. Then to find b, okay, let's say compare x squared. X squared here negative 12. Okay, so produce x squared b, and then negative minus 4a. Okay, a is equal to 3, b minus 12. Therefore b is equal to 0. And then you can compare, check, double check. Let's say take x. Here is negative 1. Negative 1 can produce x. B. This one is negative 4b. C is equal to negative 1 is equal to what? Here 0. So negative 4b is equal to 0. Then substitute x minus 4, a is equal to 3, 3x squared, b 0, c negative 1. Okay, we're going to find zeros. Zeros. Okay, then zeros. X is equal to 0, x is equal to 4, and here 3x squared is equal to 1. X squared is equal to 1 over 3. X is equal to plus minus 1 over 3. So zeros are 0, 0, or positive 1 over 3, negative 1 over 3. This one no. This one is okay. This one no. This one is no. This one, check this one. Okay, this one is actually set 3 over 3, set 3 over 3. So the answer is here. It's here. Then for this number, besides find the zeros manually, you can use calculator, and this is old version of the calculator. Maybe you have no version, so just want to show how to check the zeros. So first thing is on the and key in all this function. Okay, 3 x variable. When involve variable, you have to hit this button alpha x. Okay, x here, the pink color. Get to the power of 4 minus 12 x alpha x power of 3 minus x squared, means that alpha x squared plus 4x alpha x. Okay, and then hit the button calculate, and say that x, what's x, key in the value for x. let's say you want to test try and error, negative 1. So negative 1 equals 10. So negative 1 is not the 0. Try 0. Calculate 0. Okay, so 0. We can say that this 0 is one of the zeros of the polynomial. Okay, and again calculate 1. This one negative 6 not equal to 0. So calculate again 4. 0. So can say that 0 and 4 are the zeros for the polynomial. Okay, 0, 4. So for the second option, this is not 0 nor 4. So this is not the answer. And this is also not the answer actually. So it 1 is not the zeros. Okay, try the third option. Calculate negative, this version need to do in bracket. Okay, set 3 divide by 3, close the bracket, calculate 0. This is also the 0. Try set 3 over 3, calculate set 3 divide by 3, also 0. Okay, so this one also 0, this one also 0. 0, 4, 0, 4. So this is the option. You can test this one, negative 1 over 3, 1 over 3, or negative set 3, or set 3. So here, just try an error and choose the option. This is alternative. Okay, good luck. Number 6. Write the polynomial for the given zeros. Okay, 0. So write the polynomial. X is equal to negative 2, 0. This one roots. Then change to linear factor. Then from the linear factor, going to find the polynomial, and expand. Okay, expand this one first. Okay, the first two bracket. Okay, x squared. Okay, plus negative x. Okay, plus 2x minus 2. Okay, this one simplify. Plus x minus 2. Then the second is multiply the third bracket. Okay, x cubed minus 4x squared. The second term, plus x squared minus 4x. Then this one, the third term is negative 2 times x, negative 2x, negative 2 times negative 4x plus 8. Simplify. X cubed. This one is minus 3x squared minus 6x plus 8. So the answer is x cubed minus 3x squared. This one not the answer. Minus 6x plus 8. Okay, this one not the answer. So minus. So the answer is option x cubed minus 3x squared minus 6x plus 8. Number 7. Find the current equation of this term, okay, in the partial fraction, but there is one equation within the denominator. Okay, within the denominator. So first step is here, check. This is proper fraction. Okay, numerator degree 1, denominator degree 3. So this is proper fraction. And then this one factorize completely. Repeated linear factor. So we have 3 bracket. Okay, here is 2x over x plus 1, x minus 1 squared is equal to 3 small fraction, x plus 1, x minus 1 first bracket, x minus 1 second. Okay, here denoted is linear, so up here constant, also constant. Equating the denominator by multiplying x plus 1, x minus 1 squared. Okay, multiply this term like this. So cancel. We get that one is 2x. The next step, okay, multiply this term like this. So cancel. So the answer is a times x minus 1 squared. Okay, next is this one. Multiply this term like with this. Cancel 1 bracket. So the answer is plus b x plus 1 x minus 1. The last one is choose this one. Select this term. Multiply this term by this, then cancel. Just get 1 bracket. Okay. So plus c times x plus 1 and compare answers. A squared, this is not A squared, not the answer. A squared, B looks like this one, B. Let's see. C is cancel. This one A cube, cancel. The answer is this one, B. The answer is B. B. Okay. Number 8. Given cos x equals y, find sine pi over 2 minus x. Cos x, this is x. This is angle x. Value is y over 1. Y over 1. Using the Pythagoras Theorem, this side is 1. Set 1 minus y squared. We're going to find sine pi over 2 minus 1. So here is 90 degree minus x. So total for this angle for this triangle is 180. 90 plus x. Here should be, so this angle should be pi over 2 minus x. So when you want to find x, okay, sine pi over 2 minus x. So this one, okay, means that here over this, okay, opposite over hypotenuse. So sine pi over 2 minus x is equal to y over 1, or is equal to y. Answer is y. Okay. Or you can use a compound formula. Okay. Expand sine pi over 2 cos x minus cos pi over 2 sine x. Cos pi over 2 is equal to 0. Okay, this one is equal to 0. This one is equal to 1. So the answer is cos x. So cos x is equal to y. The answer is, either you use triangle or you use compound in the formula. Okay. Evaluate cos x plus y, where x, y both in the fourth quadrant. If sine x given negative 3 over 5, sine y negative 5 over 13. So, okay, triangle. Angle for x. Okay, angle x. Sine is 3, 5. Using the Pythagoras Theorem, 4. Okay, the next is, okay, sketch for angle y. Sine is 5, 13. So here it should be 12. Okay, then we're going to find cos. Okay, cos x plus y using compound angle formula. cos x and cos y minus sin x sin y. Substitute. Okay, now given sin x is equal to negative 3 over 5, sin y is negative 5 over 30, and you're going to find cos x is equal to 4 over 5, cos y is equal to 12 over 13. In the fourth quadrant means cos positive, cos x positive, cos y also positive. And then simplify. If I get 48 over 65 minus positive and negative, this one negative 15 over 65, then simplify, answer is 33 over 65. 33 over 65. Okay. Number 10. Simplify sin x plus sin y over cos x minus cos y. Okay, here is using the factor formula sum to product. Okay, sum to product. S plus S is equal to 2SC. C minus C is equal to negative 2SS. And it's equal to, the first one is S plus S. 2 sin x plus y cos x minus y. This one is over 2 divided by 2. Okay, and over, okay, negative 2 sin x plus y over 2 sin x minus y over 2. Y over 2 because this is 2 and 2 over 2 inside the angle. Wait, I remember. Okay, and then simplify, cancel, also cancel, and then is equal to negative cos x minus y over 2 over sin x minus y over 2. This one is equal to cot tangent. Okay, is equal to cot tangent x minus y over 2. Negative cot tangent x minus y over 2. This is the answer. Okay. Number 11. Given sin x equals 8 over 17, x obtuse angle. Okay, then the value of this one. So let's sketch a diagram triangle. X, this x, 8 over 17. Using the Pythagoras Theorem, here should be 15. Okay, obtuse angle. So this is the obtuse angle. Below here is reflect angle, and the first quadrant is acute angle. So this x angle lies in the second quadrant. So you're going to find cos 8. Here cos x is equal to 15 over 17 and negative. Why? Because of here cos in the second quadrant should be negative value. Then okay, continue. 2 sin x plus cos x over 3 cos x plus 5 sin x. Substitute value here 2 3 plus 5. Okay, so sin x is equal to 8 over 17. 8 over 17. Then cos x is equal to negative 15 over 17. Negative 15 over 17. Simplify. 16 over 17 minus 15 over 17 over negative 45 over 17 plus 40 over 17. Okay, simplify, and answer is, this one is 1 over 17 negative 5. So 17 over negative 5, and cancel, get 1 over, or negative 1 over 5. Negative 1 over 5. Answer is this one. Okay. Number 12. Okay. Tangent x is equal to 3 over 4. Number 12. Given tangent x equals negative 3 over 4. Okay. X lies between 3 pi over 2 to 2 pi. 3 pi over 2 is equal to 270 degree. This one is 360. Okay. And then find 2x. 2 sine 2x. Okay. First thing, region or range. Range in within the 270 to 360 here in the fourth quadrant. Okay, and then tangent x is equal to 3 over 4. Okay, from the right angle triangle, we try to find sine of cos. Right? So this one is x. Tangent x equals 3 over 4. 3, 4, Pythagoras Theorem. This is 5. So from here is sine x is equal to 3 over 5 negative. Why negative? In the fourth quadrant, sine should be negative. Cos x is equal to 4 over 5 and positive. Fourth quadrant. Okay. And then starting from this one, 2 sine 2x, we're going to find 2 sine 2x. Okay, is equal to, using the double angle. Okay, 2. Okay, this one, sine 2x is equal to 2 sine x cos x. Then, okay, 2 times 2 is equal to 4 sine x cos x. Sine x is equal to negative 3 over 5. Cos x is equal to 4 over 5. Then, simplify. 4 times negative 3, negative 12, times 4, negative 48. Over 25. Answer is negative 48 over 25. Okay, this is the answer. Okay, settle for number 12. Number 13, solve cot x. Cot x minus tangent x is equal to 0. And x lies between 180 to 360. 180 to 360. This one, the range or domain. Okay. Then from here we need to simplify. Cot is 1 over tangent. Okay, this one tangent. Let's say change to 1 over tangent x minus tangent x is equal to 0. Or bring tangent to the right and simplify. Okay, if this one equate the denominator, 1 minus tangent x squared over tangent x is equal to 0. It implies that 1 minus tangent x squared is equal to 0. And okay, tangent x not equal to 0. Okay, tangent x not equal to 0. Tangent x not equal to 0. It implies that numerator should be 0. Okay, and then simplify. Tangent x squared is equal to 1. Therefore, tangent x is equal to plus minus 1. Okay, and you have two cases, positive and negative. Okay, we do here. Okay, here. For tangent x is equal to negative 1. The second case is tangent x is equal to 1. Then using the for that, find the basic angle and find the x. So let's say that this one is tangent alpha, basic angle, equal to 1. Therefore alpha is equal to 45. Okay, so range given range is here. Okay, so range is x lies between 180 to 360. Okay, so this is the one. The range is from here to 360, positive anti-clockwise direction. And then for tangent negative. Tangent negative means that this one in the fourth quadrant. Okay, the line, and the answer is only 1. Therefore, x, and this one is quadrant. Okay, first that quadrant, third that quadrant, and the fourth is least. Okay, x is equal to, okay, this one x is equal to, okay, starting here, actually this one is, basic angle is 45. 360 minus 45 is equal to 315. Okay, done for this case. The second one, find the basic angle. The basic angle or direct. This one x is equal to 45. Enough. Why? Because this one is positive and positive. Then let's say check the range. The range is from 180 to 360. And then for tangent positive, that's in the third quadrant. Okay, this is here. This is the line. Okay, this is the answer. One positive answer. So here, write down x. And this the first x is equal to 180 plus 180 plus 45 is equal to 225. Okay, so answer is, for all, answer is, therefore x is equal to 225, 315. Just two answers. Okay, two answers. 225, 315. So this answer is 315. Okay. Number 14. Simplify sin theta over 1 plus cos theta plus 1 plus cos theta over sin theta. Equating the denominator. Sin theta over 1 plus cos theta plus 1 plus cos theta over sin theta. Equating the denominator. And then get sin theta squared plus 1 plus cos theta squared over 1 plus cos theta times sin theta. Then here expand this one, 1 plus 2 cos theta plus cos theta squared. I use this concept, a plus b squared is equal to a squared plus 2ab plus b squared. Okay. Then over 1 plus cos theta times sin theta. Okay, do not expand this. Okay. The next step here, sin theta squared, cos theta squared. This one is using identity. Cos theta squared plus sin theta squared is equal to 1. So now sin theta squared plus cos theta squared is equal to 1. So 1 plus 1 plus 2 cos theta over 1 plus cos theta times sin theta. And then here is 2 plus 2 cos theta over 1 plus cos theta times sin theta. Now I continue this one. Is equal to factorize 2. 1 plus cos theta over 1 plus cos theta times sin theta. Here is 1 plus cos theta over 1 plus cos theta. Can be cancelled. The answer is 2 over sin theta, or 2 times cosecant theta. 2 cosecant theta. Here. Okay, this is the answer. Number 15, simplify, starting from square root of 2 plus, and then square root of 2 plus 2, and this one is cos 4x. Okay, so cos 4x using the double angle. Double angle is right. Okay, 2 plus square root of 2 plus 2. Here is 2 cos 2x squared minus 1. Double angle. This is double angle. Okay. Double angle is cos 2 theta is equal to 2 cos theta squared minus 1. And then when theta change to 2x or 4x, this one 2x. Okay. And simplify. Okay, simplify. 2 plus expand. Okay, 4 cos 2x squared minus 2. 1 can be cancelled, 0. Then answer is okay, square root of 2 plus, here is 4 cos 2x squared. Then is equal to 2 plus, here is square root, so 2 cos 2x. Next, okay, we apply another one, another more to double angle. This is double angle here. Okay, so 2 plus 2 and double angle, 2 cos x squared minus 1, and is equal to square root of 2 plus 4 cos x squared minus 2. So can be cancelled. Now answer is square root of 4 cos x squared or 2 cos x. Answer is 2 cos x. 2 cos x. This is 2 cos x. Okay, answer 2 cos x. Number 16. Express sin x. Sin x minus cos x in the form of r sin x minus a. Okay, r positive, a is acute angle. A lies between 0 to pi over 2. Acute angle. Okay, so now expand on the right hand side. Sin x using the compound angle formula. Cos a minus cos x sin a. Then r sin x cos a minus r cos x sin a. And compare left and right contradiction. This term is equal to this. Or you can take all. Take all this is equal to this term. R sin x cos a is equal to sin x. Therefore, answer r cos a is equal to 1. Okay, you may skip that. Okay. Then for the second term, let's show this one is negative. So this one, this term is equal to this term. Take all. R cos x sin a is equal to cos x. Cancel this one, cos x. Cancel cos x. So r sin a is equal to 1. Then cancel. Can skip this step. So this one named as equation 1, equation 2. Equation 2 divide equation 1. Okay. So r sin a over on the left, divide on the left, r cos a is equal to 1 over 1. Therefore, cancel. Tangent A is equal to 1. Find tangent A. Therefore, A is equal to 45 or pi over 4. Settle for A. So this one settle. This one settle. We're going to find R. Okay. To find R. Okay. Just sketch simple right angle triangle. And this one is actually angle A. Follow this one A. Okay. Then R sin A. Actually sin A is equal to 1 over R. Cos A is equal to 1 over R. So sin A 1 over R. Cos A 1 over R. Using the Pythagoras Theorem, 1 squared plus 1 squared is equal to 2. So write down everything here. Okay. Sin. Okay. Therefore sin x minus cos x is equal to R sin x minus A, and then replace, substitute. Okay. R is equal to 2. A is equal to pi over 4. So okay, sin x minus cos x. Okay, the expression is 2 sin x minus pi over 4. Okay, the answer is number 17. Find the minimum and maximum value for this one. So, okay, depends on the cost. Okay, 1 over 2 something plus 3. So depends on this one, this term. Okay, because of the graph is, okay, the graph is from 1. The minimum is at 1. Maximum is 1. So just substitute the minimum for cos this term is equal to -1. The maximum for this term is equal to 1. And then so this one is equal to 1 over 1, 1. And then this one is equal to 1 over 5. 1 over 5 is less than 1. So this one is minimum for this term. And maximum for this term. So minimum is 1 over 5. Maximum is 1. So this is the answer. So done.